Yeah, because I still have people out.
Are you going to record online?
I can. Please. Okay, so here's what I want to know. Remember that yesterday we did the cheat chart for sine and cosine, okay? So we had 0, pi over 2, pi, 3 pi over 2, and 2 pi. That was our cheat chart, right?
Yeah.
Yeah.
Don't you want that in your pocket?
Yeah, I'll get it.
Okay, it's just not moving.
Okay. Yeah, because it's walking around and I didn't want it following me back to my desk. Okay. So tell me about tangent. What is tangent at 0?
0.
0. What does that mean it is on a graph if it is on 0? It is a what? A what?
Undefined. Parallel.
It's a line.
No.
It's a y equals.
We're not, no, come out. We're not graphing lines, we're graphing tangent. Okay, if you tell me that tangent at 0 is 0, what is that? If I draw this right here, what does that mean? It is a what?
Straight line.
Root, thank you. That was the word I was looking for. It is a root. Okay. All right, let's play this game again and see if we can figure this out a little bit better. What happens at pi over 2? What's tangent pi over 2?
Undefined.
Undefined. What happens on a graph at a...
It's a hole.
Nolan, can you take the open scissors out of your hair? Thank you. And I don't know who cut their hair the other day that I saw a big chunk of hair in the floor after y'all did spaghetti sign
I
graph.
actually didn't cut my hair.
Okay. All right. So, tangent at pi over 2 is undefined. What happens at undefined places on graphs?
It's up and down.
Not a hole, but a line. Yes. What is this?
Up and down.
It's a vertical asymptote. Okay. So, at pi over 2 is vertical asymptote. Okay. What is tangent at pi? 0 again, so it's a root. What is tangent at 3 pi over 2? It's undefined, so another vertical asymptote. And what is it at 2 pi? It's a root. Because 2 pi is back over here at 0 again. It's the same. Okay? So here is your cheat chart for tangent. Okay? Instead of sine going root up, root down, root, tangent goes root, vertical asymptote, root, vertical asymptote, root, vertical asymptote, root. Okay? Yeah, just write it tomorrow. Okay. So, let's graph it. Okay? We have vertical asymptote. We have a root at 0. We have a vertical asymptote at pi over 2. We have another root at pi. And we have a vertical asymptote at 3 pi over 2. Okay, we don't have a 2 pi. That's okay. Tell me where the vertical asymptote would be on this side of the graph.
On the negative.
Negative pi over.
Negative pi over 2 and negative 3 pi over 2. Where would another root be? At negative pi. Okay. Now, look at your...
Negative 2 pi.
Yeah, negative 2 pi. We just can't go that way. Okay, grab the unit circle that I handed you on your desk. Okay? Okay. Here's what I want to know. Here's what I want to know. In between 0 and pi over 2, so I'm talking about this chunk of the unit circle, is tangent positive or negative?
Positive.
Positive, right? In quadrant 1, tangent is positive. So our graph goes like this and hugs asymptote. Where we know it hugs asymptote. Okay? Okay? Now, what is tangent in this quadrant?
Negative.
Negative. So from pi over 2 to pi, it is negative. It goes like this. Okay? What is it in quadrant 3?
It's positive.
Positive. So my graph goes back. You see what the pattern is?
Uh-oh.
But wait.
This is getting
How do you harder and harder?
Huh? Okay, listen. We are not going to find exact points in there. Okay? Because what you're going to have to be able to do on the dual credit test is to look at an equation. If you can figure out where the roots go and where the vertical asymptotes go, you should be good. Okay? Let me finish doing the graph and then y'all can ask questions. what goes here? What do you think is going to go here? Yeah, it's going to go down. Okay, what's this? Up.
Damn.
There's your pattern. Okay? So, let's answer some questions. Yes?
Okay, so how did you know to take it up and take it down?
I looked at what tangent was. So 0 to pi over 2 is quadrant 1. Tangent is positive in quadrant 1. So it's got to go positive. Okay?
Yeah.
In that section. So now when I move to this section, tangent is now negative. Because it's a negative it's a negative x and a positive y. So negative tangent, that means it's got to go down in that chunk. Okay? Now, did you notice I'm not finding any exact points except where's the root and where's the vertical asymptote?
Y'all.
Okay? All right, let's talk about the period. Okay? This one is different. It is not 2 pi. Because this chunk right here is one piece of the tangent. You know, like sine, we had a full wave. Okay? Vertical asymptote to vertical asymptote is 1 period. So how far is that? Pi. Okay? It takes pi. I went from negative pi over 2 to positive pi over 2. That's pi apart. Okay? All right. Let's talk about range. Range is all real numbers. Why? It's going like this forever. Yes? So the range is all real. Okay. But that's not range. Range is y.
Oh, right.
Okay? That's the domain, which is x, okay? So we do have to put something in there with the x. So x cannot equal everywhere that there is an asymptote. Okay? So if we look at this, we have 1 at pi over 2. We have 1 at 3 pi over 2. Where would the next one be?
5 pi over 2.
5 pi over 2, then where? 7 pi over 2, and so on and so forth. Does everybody understand? Okay? So it would actually be plus or minus those, right? Because it's the same places going on that side. Okay? Now, we are not going to worry about a formula for the asymptotes. We are going to build our cheat chart and build our graph from there. Okay? What do you think, just hypothetical, what do you think is going to happen if I made negative tangents? What do you think that would do? It'd flip it. So instead of it going up like this, it's going to go the other direction. Okay? Almost looks like D in it. Okay? All right, I would like for you with your partner to turn the page and see if you can do cosecant. Okay? So start with the same 4 questions. The same 4 questions.
Where is Cotangent?
Third page.
Oh, sorry, it may be a couple pages over.
Third page.
Okay.
Yeah, it's
Find this one. Y equals a cotangent. Okay? Find the cotangent one.
So you just flip those circles. This one.
Okay? So start with the same 4 questions I ask you. What is cotangent at 0? What is cotangent at 90? What is cotangent at 180? What is cotangent at 270?
I don't know.
You should know. If tangent's y over x, what's cotangent?
I know why.
Yeah. See, you know that.
But then I'm supposed to be 1 over 0. That's 1.
1 over 0 is not 1.
It says there some
No!
Just yell now.
Because Katie wanted to tell me that 1 over 0 was 1.
What is the root of x over y instead like a root up? No,
It's this. It's root vertical asymptote, root vertical asymptote, root.
But that's cotangent.
X over y is. But that's just normal. Our cotangent is the same thing, right?
No, it'll be the same thing.
It's going to be
what?
flipped.
It's going to be the opposite.
So it's going to be VA root, VA root.
Yeah.
Oh, I'm so smart.
Okay, now answer the rest of the question.
Hold on, I got to write this stuff down first.
And do your graph.
No. Yeah, it goes right here. We marked the graph to here. So then we're gonna.
Yeah.
Is it going to go this way, you think?
So,
Yeah, they're.
I think I have
Wait,
an idea
because
of why
She's like cotangent's gonna be like
the cheat sheet.
Miss Ross, but this one goes this way. Is this one going to go this way?
It's just like flipping it.
Well, no, but think about, wait, come out. Yes, okay. I'll make sure you do it. Because if you think about 0 to pi over 2, cotangent is still positive. That's in quadrant 1 and everything is positive. Yeah. I was making sure you weren't going the other direction.
They look so pretty. Do people sell pomegranates here in Tennessee?
Hey,
Whoa.
Hey, just a reminder, that thing's on.
That's Darby.
Okay. So what is the difference between cotangent and tangent? Instead of starting at a root, what are we starting at? Vertical asymptote. Root, vertical asymptote, root, vertical asymptote. Okay? So on my graph, I have verticals now at all of the pi's. Okay? So it did and roots at all of the over 2's. Okay? Which direction does it curve?
the opposite of it.
It curves the opposite, okay? Now, here's how I know. From 0 to pi over 2 is still quadrant 1. Everything is positive in quadrant 1. Okay? Goes negative. Quadrant 3, from down here, everything is positive, or tangent is positive, cotangent is positive down there. Okay? So my graph looks like this. Okay? Is the period any different?
No.
No, the period is still pi. Okay? Is what's the range?
All real numbers.
Still all reals. Okay, we're still stretching forever in this direction. This way, sorry. Okay, yeah, so the domain is going to be where? X cannot be what? 0, pi, 2 pi, and so on.
Wait,
Plus
one
or
negative.
minus.
Plus or minus, yeah. It's going to go that way too. Okay? Does anybody have any questions before we try a couple of these? Yes, ma'am. Yes, ma'am.
Why does why did they go that way, that one, that way,
You have to look at where the position is. So like if you think about from 0 to pi over 2, that's quadrant 1. Everything's positive in quadrant 1. So this graph has to be positive. Okay? But it just is different position because from pi over 2 here, it's positive this way. Do you see what I mean? It's the same. The chunks on the graph actually match. It's just where the vertical asymptotes are. So if you look at this chunk, it's going down. This chunk is still going down. It's just the root is in a different spot in the vertical asymptote. Does that make sense? Okay. All right. If you will turn the page to example number 3. Hey. Turn the page to example number 3. Thank you. No, turn forward. Forward in your book. Forward in your book.
To the SEC
Mine's
one?
messed up.
So, example 3 should say y equals tangent, this one. Y equals negative 2 tan 1 half x.
No, that's
Oh,
not.
this is example 1.
Yeah, this is one.
on the back. Yours says example 1 too.
Oh. Oh, I must have printed it wrong last time. Sorry. Oh, no. Okay. Yeah, that one. Sorry. Mine's out of order. All right. Are we ready?
Yes.
Okay. So let's start. Let's start with our cheat chart for tangent. What's the cheat chart for tangent? Root,
vertical asymptote.
asymptote, root, vertical asymptote, root. 0. Pi over 2. Pi over 2. Pi. 3 pi over 2. 2 pi. Everybody okay?
Yep.
Okay. Now we have to make an adjustment in our cheat chart for this part. What does that adjustment do?
Something with flips on.
Flips across the x-axis.
No.
No.
And he turns negative.
No.
No.
Times
Moves
by two.
everything to
Times it by 2. So times everything in your cheat chart by 2. Okay, 2. 0 is still 0. What's pi over 2? Times 2.
Travis, I know you did.
Pi.
2 pi.
2 pi.
3 pi,
3 pi.
4 pi.
4 pi.
Hey, how's that 3 pi?
She just wrote.
Oh, just kidding. Just kidding. Just kidding.
You're timesing by 2, right? Okay. Now, obviously, we don't have 4 pi out that direction, but again, same thing as yesterday. Once I get a good chunk of my graph built, I can just start copying it, okay? Because it just repeats the pattern. Yes, ma'am.
What?
Prisoner of war. POW.
Yeah, but instead of head, it said like sign.
Yeah.
But like, there wasn't enough room.
Yeah, you can adjust your graph. Like once you get a good chunk built, just mirror it to the other side. You know how to do that. Yeah, then you're fine. Okay. All right, let's talk about something. I would like for you to right now. Hey, why am I having to stop every 2 seconds? Because y'all are talking. Turn all the way around so you are not tempted to talk to them. Okay. I don't need your help. Go to your graph and put your roots and your vertical asymptotes on there. And then let's talk about the graph. Okay? Put your roots, yes. So we have a root at 0. We have a vertical asymptote at pi. We have a root at 2 pi. Okay? So that I ran out of space. So now go over here and mirror on the other side.
Well, there's so much room.
Yeah, they just stretch out.
What does the 1/2 do?
We already took care of the 1/2. That's this part. I'm getting ready to talk about the -2. If I'm just waiting for everybody to put their stuff on there. Okay? Okay. Is everybody ready? All right. The tangent normally looks like this, right?
Yeah.
Okay. So question is, what does the -2 do? It makes it shoot up faster, and what's the negative do? Flip it over. So now my graph is going to stretch out a little bit more, not so curvy. I mean, it's going to stretch towards that asymptote, but it's stretching, it's not as curved. I didn't do as good a job with that one.
So why does that look like cotangent?
Okay, that's a cool thing. Well, it's the same with sine and cosine. Sine, the original sine graph, I can just shift and it suddenly looks like a cosine graph. Tangent and cotangent are the same way. If I flip a tangent, it becomes a cotangent graph. If I flip and shift, then I can make it into a cotangent graph. Okay? Yes? No. Okay, I would like for you to do this extra example, and if you will flip to the back of your packet, there's blank space on the very, very back where the flamingo is. I want you to try this extra example, y equals cotangent 2x. Go all the way to the back.
Wait, what is?
All right, try this extra example. Go all the way to the back where the flamingo is. Okay? Right, y equals cotangent 2x. Okay, build your t-chart. Your t-chart. You're not even on the right one. Go to the page with the flamingo on it and draw this.
Yeah, I did that on the wrong graph.
Hey, Miss Travis.
So the first one,
Your game's
It's an extra example. You gotta go to the back of the flamingo. Yeah. Yeah, because you're dividing by 2.
I don't believe you.
You got it.
Thank you. Stop eating games.
I can wait till you get something else.
It's all been.
It just gets it really, it does this number that does Miss Travis. It goes like, it's like,
All right, did everybody start with this cheat chart?
Oh, yeah.
Okay. So some of y'all are not on the back page with the flamingo. You're doing this on the wrong graph, and you're not going to have an example to do here in a minute. Cameron.
Listen, I even did it on the, like, when you were doing example 1, I was doing example 3.
Okay. Just saying. All right, what does this tell me to do?
Multiply by 2.
No, it does not.
Multiply by 1/2. There you go.
Yeah, you got to do the opposite down here. So I'm dividing by 2. What's 1/2 divided by 2?
1/4.
1/4. Pi over 4. Pi over 2. Now, listen, if you can't do this one in your head, then do this one and know that it's exactly in between. Right? Okay? So this is 3 pi over 4 and pi. Okay, everybody okay? So I still have a vertical, that's the only thing I have to do on this one. I have a vertical asymptote at 0. I have one at pi over 2. And I have another one at pi. So you can see what the pattern is. This one is going to be super close together.
Oh, I messed up, but forget about it.
Okay? And then we have roots in between at all of the pi over 4s. Okay? If there's any in the red bucket. Okay? What does the cotangent graph look like?
This one.
What's it do?
Cotangent goes this way.
Yep. So cotangent looks like this. Yeah? What happened to this graph?
They got skinny.
Yeah, it got squished.
Like an accordion.
It got compressed. Horizontally compressed.
I did example 2 on example 1.
Okay. Is everybody okay with this one?
Yeah.
Okay. I want you to do, go back to number 3. It looks like that. I want you to try number 3. Okay. That's your little cheat chart.
We don't even have example 3.
Oh, that one.
It's just that messed up right
Yeah.
See, I'm really tired right now, so
Alright, I'm going to assign parts here because everybody's kind of doing their own thing, so I'm going to assign parts to put on the board. So your group may get a thing. You have to answer. Hey, I want to do it.
Okay, so what would this be? 0?
Yeah. Hey, is this it?
Yeah, you should. You
You just subtract stress off, right?
What do you say?
You just subtract stress across
Yes.
So tangent sides are.
Do you subtract from greater or
She was in like.
Just copy.
Just take pi. Okay, so
I'm at pi minus pi.
No, this one, what's the opposite of this? Minus. Minus, not times. Hold on a minute, I'm talking to camera.
Oh, wait, hold on. So what are we talking about again? Because I kind of got lost.
Hey, shh. Y'all don't have to scream at each other. You're sitting right next to each other. Thank you. You have to do the opposite of what this operation is. So if it, no, this is not timesing the x by 2. It's adding pi over 2. What's the opposite of that? The opposite of adding is not dividing.
Minus.
Minus. You have to minus pi over 2.
Can I do it?
From all your stuff in your chart.
So you just minus pi over 2 to all.
That's what I just said.
I'm literally so lost.
I'm just like, you're repeating what I said in question form.
but I'm adding is
Yeah.
so is it like that?
I knew you were gonna.
All right, hey. I don't want to hear tomorrow that, oh, I didn't know how to do any of that stuff that you gave us because y'all are like totally in la la land today.
I'm asking you for me to write on the board, so I know how to do it.
Wait, let's try this. What would What would the 2 pi over 2 be?
Okay. Alright, eyeballs up here, mouse turned off. Mouse turned off. Okay. What is this telling you to do?
You subtract
Subtract pi over 2 from all of these. So that puts our first root now at negative pi over 2.
8.
Okay? Where's our first vertical asymptote?
0.
0. Okay? Where's this one going to be?
Pi over 2.
Pi over 2. Have you noticed what it's doing? Do you see?
It just shifts.
Yeah, it's shifting it. So where's this one going to be?
Pi.
Pi. Where's this one going to be?
3 pi.
3 pi over 2. Okay? So a root at pi, a vertical asymptote, or a root at pi over 2, vertical asymptote at pi, root here. Which direction does this graph go? Like this. Okay?
Is there a name for it? Is it like, is there a positive if it's like that? Like, is there like a name for like, if it's like that?
No. Not that I'm aware of, Darby. I guess there could be, but. And if you want to mirror, you can mirror and keep drawing your points. Okay? Question on tangent and cotangent. Okay. Yeah, for just a minute, because now we got to talk about secant and cosecant.
No, I'm about to lyric. There's 2.
So this is positive. But then you're gonna fail.
No.
You need to remember that this is tangent and this is cotangent. So if you remember that this is tangent, then if it's negative tangent, it does this. And if you remember this is cotangent, if it's negative cotangent, it does this. You just need to remember which one is which. Okay? All right. I would suggest that you have 2 colors for these 2 graphs, because if you don't, it's going to get weird. Okay? So if you need to get some markers, I'll get the markers out.
I got a wing snatch.
What did she tell you earlier? Turn around.
All right.
Hey, listen up, everybody. I'm going to get through this stuff.
I'm just going to wait, because I'm not yelling over y'all anymore. If we don't get done, then you're just going to have to, I'll finish recording, and y'all can do it on your own time when I'm not here. Okay. Let's talk about secant and cosecant. If you can graph sine and cosine, you can graph secant and cosecant. Okay? What does cosecant match to? Sine. Okay? So you should make a note to self that this matches the sine graph. Okay? So the skeleton, actually write it here where it says skeleton. The skeleton for cosecant is sine.
How does it match though? Oh, it's opposite.
It is, but we're going to use the sine graph to graph cosecant. Yeah. You're basically going to graph the sine graph and then turn it inside out. And so I'll show you how to do that, okay? So what do you think the period is going to be?
2 pi.
2 pi, okay? 2 pi over b, just like sine, okay? Okay, now let's wait just a minute on domain, range, and asymptotes, okay? So what I'd like for you to do is take either take your pencil, if you're using colors, take your pencil and graph the sine graph on here. Okay, graph the sine on here. So I'm going to do it in gray. Okay, so remember sine is root, up, root, down, root. Okay, so sine looks like this. Yeah. Okay, so it's not just the opposite. Okay, here's what I want you to think about. Okay, I'm gonna wait just a second. Let everybody get their sine graph on there. everybody have their sign graph on there? Okay, how do we find cosecant if we know the sign? We flip it, okay? So if I'm standing at 0 and I'm saying that the sign is 0, what happens if I flip that? It becomes, doesn't be, no, 0,
Undefined.
it's undefined. Where does the 0 flip? From the top to the bottom, right? If you flip a 0 and it's on the top and you flip it, where's it going? To the bottom, making it what? Undefined. A 0 on the bottom of a fraction is undefined. Okay? So, everywhere there is a 0 or a root for sign, cosecant is undefined, making it an asymptote.
So how does favorite word?
Everywhere that sign is 0, cosecant is undefined. Because if I flip a 0, the 0 is now in the bottom and it is undefined. Okay? Now, the cool thing about this graph is literally you turn it inside out from here because it just flips over. Okay? So do you see how I've got a little mountain right here? Now it becomes a valley, so it goes up like this.
So it looks like DNA.
So literally, you take your little mountain and you flip it. Or now I've got a valley. I'm going to take my little valley and flip it down.
So, do you do the thing every single time? And then
I do. I draw the sign graph every single time and then I turn it inside out. Okay? So, goes down like this, goes up like this.
Oh, I messed it up.
Okay?
Wait a minute, what makes it flip?
Well, cosecant is the flip of sign.
Yeah, but,
So if sign is a mountain, then cosecant is now a valley.
okay,
If cosecant is a valley, then sign is now, or if sign is a valley, cosecant is now a mountain. It just turns the graph inside out, okay? So if you were to graph this on your calculator, like if you were to type in 1 over sine x and graph it on your calculator, what parts of this is actually going to show up on the calculator? What color's on here?
The blues.
The blue. Okay? The gray is the sine graph. I just drew that to help me draw the cosecant. But the only thing that's going to show up on your calculator if you were to graph it is the blue part. Okay? That's the actual cosecant graph. Okay, what's the domain now? We got vertical asymptotes. X can't be what?
X can't be,
Pi, 0.
0,
Zero.
pi, 2 pi, yeah, plus or minuses on those, and so on.
It goes on to infinity.
Yeah, because you could keep drawing it as long as you want to. Okay? All right, what about the range? Okay, I can see why you would think that. Because the blue goes up forever and the blue goes down forever. But do you see? Exactly. So I'm going to highlight it real quick and then I'm going to delete it. Do you see how there's no blue part right here? Right? There's no blue graph right there. So if we were to write the range, it goes negative infinity all the way to -1, jumps a spot, and goes from 1 to infinity. So that's a little tricky. Okay? It jumps, see the part that I highlighted? There's no blue.
So would that be
Okay.
every single time?
Yeah, there's going to be a chunk like that. Yes, ma'am.
Yeah, I was gonna say that.
You aren't going to ask that. Y'all are correcting me.
No.
Yes. Yes, you know that.
wait, why is that not a bracket?
Infinities are never brackets. And I accidentally drew one, and so everyone has to correct me.
I never have to.
Okay. Hey, guess where the asymptotes are? Exactly what we wrote in the domain. Where are the asymptotes? At x is 0, at x is pi, at x is 2 pi. Okay? So remember that from when we graph rationals, the domain and the asymptotes completely match. Okay? All right, I would like for you to see if you can do the secant, this one, with your table partner. So what's the skeleton for secant? Y equals cosine. Okay, start with the cosine graph. Start with the cosine graph. Start with the cosine graph.
Wait, is it up, root, down, root, up?
Up, root, down, root, up. Start with the secant graph. Turn all your zeros into vertical asymptotes and flip your graph inside out. Hey, come on and do this. Graph cosine, up root, down root, up.
Is it still on the roots?
Yeah, asymptotes are always, because that's where the zeros are, and when you flip a zero over, it becomes undefined.
Alright.
I forgot root down. This isn't right here.
Miss Travis, can you put on ain't no mountain high enough, because I think it works.
He'll only want some theme music.
Can we please have some?
No, don't use
Who
your
said no?
I do. Why would there be music while we're doing that?
Did you say for Y?
For why?
I say that all the time. I say for Y all the time.
All right, so does everybody have this for your cosine graph? This should be this.
Wait, is the range the same?
Hold on, let's get,
The period is still the same.
Hard. The camera here is no, that wasn't hard. It was just.
yeah, sometimes if you keep repeating the pattern too much, you get off somewhere. I've done that before. Okay, so now you should be taking your pencil and turning all of your roots into vertical asymptotes. Everywhere it touches the x-axis is now a vertical asymptote. Okay? And then your mountains become valleys, and your valleys become mountains. Okay? Come on, Cameron. You need to be dialed in.
I am.
No.
I promise. It's almost literally the exact same thing as that.
All right, what's the period?
2 pi.
2 pi.
Oh, I am dialed in.
Okay? What's the domain now? X cannot be what?
Plus or minus
Negative 3 pi over 2.
All the pi over 2. So plus or minus 3 pi over 2. Where would there be another one? 5 pi over 2, 7 pi over 2, etc. Okay? Range. Range is the same. Range is the same. It's going to go from negative infinity to negative 1. Chunk missing, 1 to infinity. Okay? Asymptotes are the same as our domain. Our asymptotes are at plus or minus pi over 2. Plus or minus 3 pi over 2. Okay? Etc. 5 pi over 2 and on and on. Okay? All right. Yes. Okay. I want us to try a couple of these examples. Okay? And then we're done. Okay?
Oh.
Well, this is, you guys feel like it's hard because you've never done it before. Like, it's completely new. I mean, and even last year, if you did it in Algebra 2, we let you all use your calculator, your graphing calculator, because it's on the AOC and you're just matching most of the time. Okay? All right. If you will find this one, example 2, the one that says cosecant x minus pi over 2. Okay? Now, if you'll cross this stuff out, we're not going to worry about that. We're going to build our cheat chart with our pattern. So our skeleton graph, the graph we are essentially graphing is sine equals x minus pi over 2. And then we're going to turn it inside out. Because cosecant goes with sine. Yes?
We don't have that.
Okay.
I know, I messed up on my entire book. Everything's wrong on it.
Yeah, I know.
Okay. So, what is the pattern for sine?
It wouldn't be,
Root
Root
up,
up,
root
root
up,
down.
Root up, root down, root. Okay? The pattern for sine is root up, root down, root. 0, pi over 2, pi, 3 pi over 2, 2 pi.
When you add,
Okay? Yes, exactly. What are we going to do to each one of these? Add pi over 2.
Yes, ma'am.
Yeah? Okay, so where are my new ones going to be?
so pi over
Pi over 2.
one.
1 pi. 3 pi. Do you see the pattern now?
Yeah.
Do you see how it's just, so this one would be at
2
2 pi, this one would be at 5 pi over 2. Why is it fat? I don't understand. Okay.
Why isn't it fat?
So now we're just graphing. Now graph this one in pencil because then you're going to do your vertical asymptotes and turn it inside out. Okay? I have a root at pi over 2.
I'm following along.
I have an up at pi. I have a root at 3 pi over 2. I have a down at 2 pi. Okay? Now, you may want to continue your pattern a little bit back this direction. Okay? So we have this nice little curve going on.
All the pi's ends are over 2.
Okay?
Dang it, it sort of makes sense.
All right. Does everybody have this graph?
Let's see.
Okay. So, now what do I do to turn it into cosecant?
Draw the S.
Draw the asymptote. Everywhere there's a root, draw an asymptote. Everywhere there's a root, draw an asymptote.
I said it.
Now what?
You do the opposite on the whole.
Turn it inside out. So the valleys become mountains, and the mountains become valleys.
Yeah, I'm not dialed in.
Is everybody have any questions?
Oh, okay. This is actually not that bad.
Okay. Again, what part of this graph is showing up on your graphing calculator if you were to graph it?
Just the blue pink part.
Just the pink, yeah. Just the pink using mountain. Okay? Just the valleys and the mountains are the only thing that are going to show up on your calculator. Okay?
Are those have specific points or do you draw?
No, you do not need specific points because they're not going to get that. They're not going to make the graphs to where they're that precise since they're only giving you a little calculator to answer them on the dual credit. These questions are going to be matching. So they're going to give you this and then 4 different graphs and say which one is it.
How many questions are on the dual credit?
40, and you got to get
Choice?
yes, and you got to get 30 of them right to get the
Wait, I think I'm out. How much?
2 hours.
For 40 questions.
So basically everyone passes.
Absolutely not. Are you
2
crazy?
hours. This Travis, since I did like really good, they go go. Do we
Wait,
have to
to get-
pass it to
you
get
have
the
to get 30 to
extra
get what?
points on our GPA?
All right. Hey, before we leave, I want to do this one. Okay, so find it in your book. I'm sorry I copied your book all weirdo. So,
Yeah, it's back page.
yeah. So it should be next to cotangent. Is it next to cotangent? Okay. All right, let's do this one. Before you leave, we're not going to do this. Okay?
Fine.
Okay? Our graph that we're graphing is y equals negative cosine of x minus pi. Okay?
Thank you.
Let's do this one together. Everybody dial in with me. I got about 6 minutes, okay? Let's do this last one and make sure we're solid. No extra comments. Okay. The cheat chart for cosine, remember, is up, root, down, root, up. 0, pi over 2, 3 pi, 3 pi over 2, 2 pi. Let me erase that. Find it better. Okay. There we go. All right. Tell me what the negative sign is going to do.
flip it, like,
Flip what?
like,
Everything.
It's going to flip the whole graph, but what's it do to my cheat chart?
oh, it changes the arrow.
Changes the arrows. Okay, so change your arrows in your cheat chart.
Oh, no.
Okay? What does this do to my cheat chart?
Pi.
Add pi. So what's my new spot? Pi.
3 pi over 2.
3 pi over 2.
2 pi.
Oh, isn't that crazy thing? 2 pi. 5 pi over 2.
3 pi.
3 pi, which if you don't know this exact point, you can find it because they're evenly spaced. Yes? Huh, how did I miss it?
I was hearing what you were saying in like orange, but I was trying to write what was in black, and it
Oh, okay. All right, so take your pencil and now draw in your cosine. Okay? So we have a down at pi, down 1 at pi. We have a root at 3 pi over 2. We have an up at 2 pi. Okay? So now I just got to repeat the pattern going backwards. Okay? I know sometimes you run out of graph, but you just got to repeat the pattern. Okay? Then you're practically done. What's the only thing left you have to do? Draw the asymptotes in and turn it inside out.
I can't say that word.
Okay? So draw the asymptotes in at the zeros. Draw the asymptotes in at the zeros. Turn the graph inside out. I actually think these are pretty easy to graph if you can graph sine and cosine.
Good job, guys.
Okay?
Good job, please.
Okay.
It's actually easier than yesterday.
Will you press turn it off to stop recording? Just press the record button.